watch the video over the weekend. All right, Aaron and Polymon, I know you guys are talking about a derivative question, but if I get you to stop, I want to introduce you guys to product rule and quotient rule. There are like, I think 15 derivative rules that are going to come your way in this unit. They're going to be fine. Your brain can handle this. The first one is called the product rule. As the name implies, we're going to use the product rule when we see multiplication. Okay? Product means multiply. So when you see multiplication of functions, we're going to use the product rule. Now here's what the product rule says. This is not a proof, but if y equals f of x times g of x, so I'm multiplying two different functions together, the product rule says y prime is equal to f prime of x times g of x plus f of x times g prime of x. So the product rule says f prime times g plus f times g prime. Said another way, you take the derivative of the first, you leave the second one alone, plus you leave the first one alone times the derivative of the second. Everybody good? Now you guys are also going to be like, oh yeah, that's good, I got it. I have not proven anything, and you're like, it must be true. Well, let's actually see if this actually is true. So here's our first example. We've got y equals 2x squared minus 3x times x squared plus 1. And first of all, is this the kind of problem you should be thinking product rule?
Yes.
Why, Celeste?
Because two functions are being multiplied.
Two functions are being multiplied together. Good. So let's we are just blindly using the product rule here because, like, you guys believe me. Okay, and what does the product rule tell me to do?
Take the derivative of the first.
Okay, this first guy here, this is the f of x. The second one is the g of x. So the product rule says take the derivative of the first. What is that?
4x
Minus 3. And then
Leave the second one alone.
leave the second one alone. Plus, leave the first one alone times the derivative of the second, and that's 2x. This is what the product rule would tell us to do. This is not pretty. It is not an elegant looking answer, but this is the derivative. Now, you might say, sure, but I'm not 100% convinced. So there's another way. So let's look at way number 2. Anybody know another way without using the product rule? What would you have done yesterday if you had seen this problem without the product rule? Lewis has some ideas. Polymon has some ideas. What would you have done yesterday if you didn't know the product rule? Polymon. Would that be legal to multiply those two guys together?
Yes.
And then take a derivative?
Yes.
Does everyone feel pretty comfortable doing that? Okay, good. Good. So this is option 2. Option 2, we're going to hold off on our derivative skills. We're going to do a little bit of algebra. 2x squared times x squared is 2x to the 4th. All right, what's next? Plus 2x squared minus 3x cubed minus 3x. That's not the derivative, right? I'm using my equal signs here legally, using my equal signs. Now take a derivative. And Ile, this one's coming your way. Can you tell me what's the derivative of this guy over here?
8x cubed
8x cubed
plus 4x
plus 4x
minus 9x squared
minus 9x squared
minus 3.
minus 3. That's the derivative that you would have come up with yesterday. Now you probably would have written 8x cubed minus 9x squared plus 4x minus 3, but at this level we're okay. Are we convinced that these are the same? I would not be convinced. You should not be convinced that these are the same. They don't look to be the same to me. Right? This guy here, what you did is you did sort of like algebra then calculus. If the product rule actually is a thing, if I'm not just making it up, I need to see that these two answers are perfectly equivalent to each other. Polymon, what do you want to do?
We'll multiply the two of the original.
Right, let's like clean this up and let's see if it actually works. Okay, and we'll do that quickly. 4x times x squared, what is that? 4x cubed plus 4x minus 3x squared minus 3 plus 4x cubed minus 6x squared. Maybe that's got some potential. 4x cubed is 8x cubed minus 3x squared minus 6x squared minus 9x squared plus 4x minus 3. Hey, good news. They're identical. The product rule basically allows you to say, let me do some calculus, then some algebra. What you guys did this other way is you did some algebra, then you did the calculus. Same answer both times. Good news. You can use either way. If you see you're multiplying two functions together, product rule. All the friends are okay? All right, let's make this a little bit sticky. So the product rule says,
The product rule says,
we're going to take the derivative of the first
we're going to take the derivative of the first
times the second
times the second
plus the first
plus the first
times the derivative of the second.
times the derivative of the second.
Okay, faster. Product rule says,
Product rule says,
take the derivative of the first
take the derivative of the first
times the second
times the second
plus the first
plus the first
times the derivative of the second.
times the derivative of the second.
Tell somebody near you.
Product rule says,
Second.
times the
Plus
second
the
plus the
first.
first
Second.
plus the first times the derivative of the second.
Second. Plus the derivative.
Down there.
All right. All right, everybody's good? Everybody's good at the product rule. Derivative of the first times the second plus the first times the derivative of the second. Good. Quotient rule, quotient rule. Andrew, quotient rule. What does that even mean?
When you're dividing a function.
Quotient, division of functions. Division of functions. Now the quotient rule, you're going to see it as f of x over g of x. Here's the quotient rule. The quotient rule says g of x times f prime of x minus f of x g prime of x over g of x squared. That's the quotient rule. G of x times f prime minus f of x times g prime all over g of x, the whole thing squared. It's beautiful. Okay. I'm a little scared. I don't know if I'm going to share this story with you guys because I might get in trouble, and who knows who's on the other end of the camera
That's
here.
a multiplication sign between.
That's a multiplication. My multiplication dots sometimes get away from me. A way that people like to remember the quotient rule, there's a little song. They say low, D high, minus high, D low, low, low. Okay, one more time. Quotient rule, low, D high,
Low D high
minus high, D low,
minus high D low,
low, low.
low low.
One more time. Quotient rule, low, D high,
Low D high
minus high, D low.
minus high D low,
We're gonna go low now. Low, low.
low low.
Okay. All right. Low, D high. What am I really talking about?
Denominator.
I'm talking about numerator and denominator. The one in the numerator is high. The one in the denominator is low. So the song was low, D high. What does the D stand for? Low, D high, minus high, D low, 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 low. We gotta make sure we get low, low in the denominator. Everybody good? All right, one more time. Quotient rule says?
Quotient rule says,
Low, D high,
low D high
minus high, D low,
minus high D low,
low, low.
low low.
All right, now we're doing well on time. Here's the thing. If one day when you grow up and you become a calculus teacher, do not do high over ho. Because here's what happens. Here's what happens. It's cute. Ho D high minus high D ho ho ho. I was teaching this around Christmas time. It was great, Mr. Lin. Ho D high minus high D ho ho ho. And the class of 2011 or 2012, it's one of them, I'll figure it out. We're in the room. Teach for America friends come in. 20 observers come in. We're all standing up and we're doing the quotient rule. We're saying, ho D high minus high D ho ho ho. And everyone's doing it. And I'm like, where's the high? And everyone points to the numerator. And I said, where's the ho? And everyone pointed to the same girl It was so bad. Instinctively, they all pointed to the same person, and I was like, ah. So forever, high and low. Giselle, I have not seen you smile so much in a very long time. All right, so here we go.
I'm dead.
Yeah. I need this job. Okay.
I'm glad we retold it.
All right. Derivative of 1 over x. Is this a quotient rule problem?
Yes.
Is this quotient rule?
Yeah.
Is quotient rule the only way to go?
No.
Stephen, what do you see? If you didn't know the quotient rule, could you find this derivative?
Yes.
How would you do it?
Just I guess reverse the x on the denominator.
Okay, right. Rather than 1 over x, you guys would have made this x to the negative 1 power.
Yes.
And then the power rule would tell you to
Bring the power down.
bring the power down and subtract 1 from the power. Everybody okay? And so the power rule would get you negative 1 over x squared. This is what you get less if you're going to use the power rule. Let's use the quotient rule. Okay, quotient rule. Quotient rule says what?
Loading high.
Okay, so the derivative of 1 over x, I want to be really careful with my notation, guys, over here. A derivative of 1 over x says low d high. What's low? X, what's d high? Be careful.
Zero.
D high, here's the high. What's the derivative? 0. Low d high minus 1. D low. It was low d high minus high d low. Derivative of x is 1. Low. X squared. At first glance, it does not look to be the same. But you guys know. You guys know. Right? X times 0 is 0 minus 1. We're going to get negative 1 over x squared. Everybody get the same thing? Power rule, quotient rule. You have a choice in this problem. Product rule, quotient rule, the only two things I wanted to introduce you guys to today. Yes?
Will, like, the question ever say use this rule specifically?
That's absolutely a possibility. Most of the time, though, you're going to have a choice. So I want you guys to have a little bit of time to do these two problems. I know it says model problem. We're not going to worry about model problem. I think you guys should be fine. I want to make one small change, though. And that is in model problem number 1. It says v of t equals square root of t. No. Just t. So v of t is t over t squared plus 1. Problem says velocity of a particle moving along the x-axis measured in meters per second can be modeled by the function v of t equals t over t squared plus 1. Including appropriate units, determine the acceleration of the particle at time t equals 4. Have a quick strategy conversation with somebody near you. What are you going to do?
He's asking for acceleration, and then the graph is telling you velocity.
I'm really sorry I couldn't join you guys for the picnic. I wanted to be there.
Me too. We all wanted to.
We all wanted to go to the picnic. Okay, how are we going to find acceleration? Right, because you're starting with velocity. Acceleration is going to get me through. Okay.
First.
Make sure your derivatives looking good here. Can I just get a quick thumbs up? How many guys derivatives matching mine? T squared plus 1 times 1 minus t times 2t over t squared plus 1, the whole thing squared. Low, d high, minus high, d low, low. All the friends are good? Lewis and Andrew, you guys good back there? All right, that's not the final answer. The final answer is acceleration at 4. So 4 squared plus 1, what is that, 17? Times 1 minus 4 times 8 over 16 plus 1 squared. 17 minus 32, that's 17. Anybody have 17 squared handy?
17 squared?
Yeah.
Ooh.
Okay, here's the good news. If this was the free response part of the test, you could stop here. You could also stop here. These are both safe stops if it's free response part of the test. In the event that is the 289, there you go. I knew somebody besides me was packing that. 17 squared is 289, 17 minus 32 is negative 15. Negative 15 over 289, love it. Free response though, you can stop here, here, or here. Once you hit number, stop. I need units,
Meters per second squared.
right? The velocity was being measured in meters per second, so this must be meters per second. Everybody okay? Okay, this is not written into this problem, but I want you guys to figure out what is the speed doing at t equals 4. What's the speed doing, and I want a justification here. So we'll call this like part B. Speed at t equals 4. What are the thoughts on speed? Speed is either increasing or decreasing. And to make this decision, we need to look at two things. Velocity and the acceleration. We already know the acceleration. We know the acceleration came out to be negative. The velocity. Alright, in order to make any decisions about speed, I'm going to have to find the sign of the velocity. Velocity is positive at t equals 4. The acceleration at 4 is negative. I don't care that it's negative 15 over 289. I care that it's negative. So if velocity is positive and acceleration is negative, our conclusion? The speed is... Be careful. The speed is decreasing. Where is the speed decreasing? At t equals 4. Good. All right, try the next one, see what you can do. And then we're going to go a little crazy. All right, I'll take care of stickers for the rest of the friends. Who else earned a sticker? Is that okay? Myra?
Martin, Jordan.
No, I didn't because she's lazy.
Andrew, Lewis, or Steven, any stickers?
I also got a sticker.
Aaron got a sticker.
I got all of this already,
No, that was part of the issue.
But I didn't need the E-minor, so I just kept bringing it down because I was just over prefixing the rest of that.
It's still wrong, so no sticker. These are expensive stickers. It was like $1 for like 5,000 of them. All right, Eileen, no sticker yet? That's right, there's. Everyone is gonna earn every single sticker.
Or do you use that? No.
I'm gonna let you dangle for a little bit.
Oh, never mind, I see it.
I wanna let you
I
dangle.
saw it.
You have
All right, seeing some good stuff. If we're going to get the equation of a tangent line, we need two things. We always need the same two things. I need the point, and I need the slope. Now I'm seeing out a lot of papers. We know that P of x, and here's like the work I'd want to see. P of x equals G of x times H of x. So I need P prime. P prime product rule is going to be G prime of x times H of x plus G of x times H prime of x. Now, I saw in most papers that people are taking the derivative, they're using the product rule. Why? Why are we even taking the derivative? What's the derivative going to get you that you don't already have? It's going to get you the slope of the tangent line. Specifically, what you need is the slope of the tangent line at 4. Right, it is 4? Okay, so P prime of 4. Now, write out as much as you need here. What's G prime of 4? G prime of 4 is -2. H of 4? -1 plus G of 4 is 3, and H prime of 4? 4. I would at least want to see that you like found that first derivative. That would give you like a point. P prime of 4. What is that? 2 plus 12, I think that's 14. Second point. Now I want the equation of the tangent line. I've got the slope of the tangent line. What I need now is the point. Where's the point? Right? The point is always going to look like there's an x-coordinate and a y-coordinate. We know the x-coordinate is 4. I need the y-coordinate. The y-coordinate is not 14. The reason that you found this, Aaron, this is your slope.
-3.
It's -3? Tell me why it's -3.
We had to use the first function that they gave us.
Right, the first function that I gave you is still in play here. The y-coordinate is whatever you get by finding P of 4. P of 4 is going to be G of 4 times H of 4, so this should be the point 4 comma -3. I've got the slope, I've got the equation, I've got the point L of x should be, what is that, 14? X minus 4 minus 3. I'd say that's your third point. How many guys made it all the way to the end there? I see 1, I see 2, I see 3, I see 4. We're doing okay? Product rule, quotient rule, just 2 new tools in the toolbox. Now, do not be deceived. Don't think we've proven the product rule. This would not hold up in mathematical court. You're just sort of blindly using it. You have faith in me and my teaching skills, and I do appreciate that. All right, let's see how smart you guys really are. Try number 4 on page 12. Even if I'm writing over here, can the friends at North Central and Eastern see it?
Yes.
Okay, thanks, Steve. Okay, C is constant. Equation of tangent lines.
C would just be gone. C would just be gone, right? C technically is just like 2 squared, so taking the derivative of that would be gone.
Yes, but they're not canceling here.
Oh, they're not.
They're canceling in the derivative process.
It's just 2x. Negative 2x equals -1x.
All right, what I'm seeing in pretty much everybody's paper is we are clearly going to use quotient rule. Right, quotient rule should scream at you. You're like, I'm a quotient. All right, so the quotient rule says low, c squared plus x squared, d high. What's d high?
Oh, 2C2
I heard 2c minus 2x, and that is so sad.
Wait. Oh,
I heard that the derivative of c squared minus x squared is 2c minus 2x.
no.
It is so sad, David. Why is that so sad?
Oh, because he's a constant.
One more time.
C is a constant.
C is a constant. If I had written 3 squared minus x squared, everybody would have said 0. C is a constant, C squared is a constant. So the derivative of the numerator is just negative 2x. Low, D high, minus, now I need the high, C squared minus x squared, D low. D low is, what is that, 2x? Over C squared plus x squared squared. This is a beautiful derivative that does not need simplification. Don't simplify it unless you're just like, I have to. I would strongly encourage all of you guys to just get in the habit, especially with the quotient rule, to use parentheses, because that minus sign is supposed to impact everything that comes after it. So be really, really careful. All right, I want the equation of the tangent line. You guys know what I need. I need f of 0. What is f of 0? Not f prime, but f of 0. C squared minus 0 squared, C squared plus 0 squared, which is just 1. F prime of 0, let's find f prime of 0. F prime of 0, C squared, C still a constant, plus 0 squared. C squared times negative 2 times 0. Oh, how nice. Minus C squared minus 0 squared. C squared times 2 times 0. Oh, how nice. In the denominator, C squared plus 0 squared squared. You guys know what that's equal to?
0.
This should just be 0. F of 0 is 1. F prime of 0 is 0. The equation of my tangent line is going to be my slope times x minus 0 plus 1, or even nicer, just L of x equals 1. Quick show of hands. How many of you guys honestly came up with the right derivative? The right derivative. Okay. 1 point, possibly 2 points. Then putting all of this together, coming up with the equation of the line. Third point, maybe even a fourth point. They might award a point for something like this. But we need to be able to like play this game on lots of different levels. Lots of different crazy things are going to happen. Like this last one. I am so excited. I didn't think we were actually going to get to this one. But we are. This is the hardest problem I could come up with at this point in the course. I'm going to give you guys a minute or two to talk about this, come up with your plan of attack on this closing model problem. Take some opening thoughts on this one. What are the thoughts that are out there? Stephen, what do you got?
Maybe f of x is a piecewise function.
Maybe you want to think about f of x as a piecewise function. Legal?
Yes.
Absolutely. Okay. Other ideas that are out there? Celeste, what thoughts do you have?
Find the equation for the graph of f of x.
Okay, find the equation for the graph of f of x. I think this is kind of like what Stephen's idea was. Let me find the equation. I mean, these are just 2 lines. That's not too bad. I could possibly do that. Lewis, what other thoughts are out there?
Just find that at x equals 1, f of x is 2.
At x equals 1, f of x is equal to 2. I agree with you. So we've got this point over here that when x equals 1, f is equal to 2. I agree with that. But my goal is to find the equation of the tangent line, which means I need a point, I need a slope. Right? We're always going to go back to the point and slope. All right, so the point says x equals 1. I'm not looking for what f is at x equals 1. I'm looking for what g is. So what's g of 1? Right, because I want the equation of the tangent line to g at x equals 1. G of 1, I'm going to have to use my definition for g here. G of 1 says it's the cube root of 1 times f of 1. Oh, that was awkward. F of 1, I do know from the graph that f of 1 is equal to 2, and the cube root of 1 has to be 1. So we've got 2. Great. I've got the point. What's missing, the scary part that's missing is the slope. For the slope, I need f prime of 1. Yes. Oh, not f prime of 1. Oh, so awkward. G prime of 1. Yes, I need a derivative. How are we going to find the derivative? G of x is the cube root of x times f of x. Myra, what do you want to do? This is the product of the problem. So if g of x is the cube root of x times f of x. Now here's the thing. I know you guys know the product rule. The product rule says take the derivative of the first, leave the second one alone, plus the first times the derivative of the second one. I want to introduce a new, not a new notation, but a way to think about this that's going to help organize your thoughts a little bit. The product, just using the product rule here is going to be rough, because I have to take the derivative of the cube root of x. Rather than finding the derivative of the cube root of x, right now I'm just going to say, hey, I know that I need to do this. I'm not even going to bother finding it right now, but my notation, this is why the notation is so important. The notation says, hey, I'm going to find the derivative eventually, and then what do I do? The derivative of that times f of x, yeah, plus
No, just 3.
plus the cube root of x. So derivative of the first one, I still have to do this, times the second, plus this guy here, times the derivative of f. Anybody have a good way to write derivative of f?
Prime of x.
F prime of x. That is for sure going to get you at least 1 point, possibly another one. But be careful, you're not done. You're not actually done with the derivative until you can tell me what the derivative of the cube root of x is. And if I'm being really clever, I know that there's some legal stuff I can do here with the cube root of x that would make finding the derivative better. Make it x to the power of 1/3. So the cube root of x, I'd really make this x to the 1/3 power. Now finish your derivative stuff. Derivative of x to the 1/3, bring that power down. X to the negative 2/3 times f of x plus the cube root of x times f prime of x. That's probably going to get you the second point. Here's what I really care about. Is everybody okay with what just happened over here? If that's good, everything else, even if we don't go anywhere else, I'm fine. But here's what we really need. We need g prime of 1. Okay, let's get g prime of 1. G prime of 1, I can't see it because now I'm blocking, says 1/3 times 1 to the negative 2/3 power. 1/3 times 1 to the negative 2/3 power. You guys know what that is? Not 1. Right. 1 raised to any power has to be 1 times 1/3. F of 1, 2, plus cube root of 1, 1 times f prime of 1. F prime of 1 means slope of the tangent line at of f at 1.
The 1/2.
What's the slope of the tangent line here?
Negative
Negative
1/2.
1/2.
Is it negative
1/2.
1/2? 1/3?
1/2? No, yeah, negative 1/2.
Right, I'm going to need another point that I know for sure that's on this line. I go down 1, I go over 2. So that's going to be a negative 1/2. All right, we've got, this is 2/3 minus 1/2, which I think is 1/6. Even if it's not 1/6, I don't care too much. That's the slope equation of your tangent line says L of x is 1/6 x minus 1 plus 2. I love it. Not the final answer though.
That's what you want to do.
Right, now I just need to estimate g at 0.8, which is going to be 1/6 of 0.8 minus 1 plus 2. Nice. Nice, nice, nice. All right, this weekend's homework is real. It's like, I think 5 problems, 6 problems total, all involving product rule or quotient rule. Nothing is going to be as hard as the ones that we've done today. You guys are going to be good. North Central, enjoy the picnic. East End, I don't really know what you guys are doing, but have a good weekend.